Good evening, everyone. Give a well introduction to the what blockchain is, and Dr. Chandana very well explained what can you blockchain. We thought the next step would be to getting started with developing. So although we introduce it as it's getting started with blockchain, yes, introduced by Hasharin, but we specifically limited to Ethereum because otherwise there will be a lot of blockchain implementations like Hyperledger, Stellar, a lot of things. So first thing I think I would mention is before getting started developing, you should really know what type of application you are going to build. Like maybe you need to build a fully trustless system, or maybe you may need to build a semi-trusted system. So depending on that, you may need to decide what sort of implementation you should select. So basically, Ethereum will be suitable for a fully trustless system. And if you're going for a semi-trusted system, there may be implementations like Stellar. So first of all, think about it. And I think to understand the basic concepts of blockchain, I think Ethereum will be a good point to start. And having said that, so yes, so you all got to know, and you may have earlier known about blockchain basic concepts. From here, what I meant was before getting started with developing, just read the white paper. That will really be useful because if you don't know what's happening under there will be really meaningless, just using the tools around here and there. And if you really want to know what's underlying math governing there, better refer the yellow paper as well. But it's more mathematical, and sometimes you may find it hard to digest, but it's worth giving a try. And so first of all, what is a debt? So when you are developing with blockchain, you are basically developing decentralized applications. Well, what do you mean by a decentralized application? It basically means the application itself does not depend on any specific party. That means as Dr. Chandana mentioned, you are not going to depend on a central authority. So in that case, then what would be the backend sort of thing in application? That is the online peer-to-peer network. Having said that, then you need to know there are, when you take an application, there are a lot of the major target is the users. So basically, users are not technical, so they can't run a client Ethereum client in your machine and connect to blockchain. So you should provide a user interface. So that part is the front end part. So it can be hosted in a central server, and you give it to the user when he requests through a browser, or maybe you can again use a decentralized storage like Swarm or IPFS. And when it comes to Ethereum, the decentralized network is the Ethereum network, and the depth, then you can call it front-end and smart contracts. As Inosh mentioned, smart contracts are like digital. It's sort of a piece of programming code that will execute in every peer. So what is this cross D? It's just using it only in Ethereum because that cross D in Greek is pronounced as eth, and you can call it as either distributed application or eth application. Just a fact, and it is not very useful for you. So when it comes to smart contract development, as I said, it's a piece of code. So you need to choose a language to develop it. So there are a lot of languages out there: Solidity, Serpent, LLL, and those things. Even I am only familiar with Solidity, and Solidity is the most popular and widely supported one. Even in 2018, only Solidity has commits in 2018. Other languages only so far has been committed by the community only up to 2017. So I think Solidity is the best option to go. And as I mentioned, it's a high level. Those other languages are, some of them are more related to low level. So Solidity is a high level language, as most of the programmers are using JavaScript or maybe Python, anything. Like most of us are using high level languages. So to get started with Ethereum, I think Solidity is the best option. And Solidity is a Turing complete language. I think you all may know what a Turing complete language is. That means you can basically do like any sort of, you can implement basically any sort of logic there. So then that means that the powerfulness of Ethereum, like so syntax is basically like JavaScript, and it is said to be contract-oriented programming when you're developing with Solidity. That means you like when you're programming with object-oriented principles, you inherit from classes, and in Solidity you inherit from contracts. So that sort of thing. That is why it's basically called contract-oriented programming. And main thing, it has rich documentation. So all of any of us who want to get started with something, as programmers, what we all look is for a solid documentation. So Solidity has it, and the ID, Remix ID. Remix ID is the, I think it's the best option you to start with. So I'll go into that. So Remix ID is basically a browser-based IDE. You can like have it, use it online. You just go to remix.ethereum.org, and you can basically program your code. Or either you can have it running offline. Like if you really don't want to have this internet connection, you can have offline usage as well. And then I think the best thing is to write code and compile. You go there and see the user interface is really self-guiding. And if you really go there, they have a sample contract as well. So you don't really need to program at first. You can just try deploying, sending transactions without even writing a piece of code. So as I said, the Ethereum Remix ID is basically self-guiding. It has self-guiding user interface, but I thought it's better to mention that it is also there in the, like you can easily see it in the interface if you go there. But I thought it's better to mention that there are 3 environments that you can use to deploy your contracts. That means basically you're sending a transaction to the Ethereum network. So those 3 environments are JavaScript, virtual machine environment, injected Web3 environment, and the Web3 provider. So here Web3 is basically a wrapper for like you to talk with the Ethereum network. Like basically you're sending HTTP request with Web3, but the Web3 is your task with those wrappings. So JavaScript virtual machine, what it does is like it simulates a Ethereum virtual machine. So you can easily test your contract without even having a local Ethereum, without even getting connected to a network. So to use injected Web3, I think the best tool is to use install MetaMask. It's a browser extension, and it gives you the ability to connect to any sort of network out there, Ethereum main network itself, and the test nets, and even to a custom network that you have, like you can have a local private network running in your own machine. And MetaMask can also be considered a wallet. So basically, you can have multiple accounts stored there. actually, I'll like introducing you the tools. You will, when you get using it, like these specs will be useful to you. Now, maybe right now it makes no sense to you. So Web3 provider is like basically connecting to an actual network rather than doing with a JavaScript virtual machine. Web3 provider, by using Web3 provider option, you can either connect to a private network or like if not, you can use Infura node. That means Infura is a service run by this consensus company. That means they provide their own nodes, and they give that endpoint for you to access Ethereum networks, main network, or test networks for free. And that will be really useful for you. And this truffle testnet means there's a truffle framework that I will introduce later. So that with that also you can have a sort of a private network running in your machine. So after that, once you have developed deployed the contract, you can interact with the contract, maybe using the remix ID itself, or you can use, if you deployed it to a test network or something, you can use more Ether wallet, or like if you use a truffle network, you can use the tool Ganache, and for just to view the transaction, you can use Etherscan. So we will be sharing these slides. So if you get started developing it, you can just refer what sort of tools you can use. And I would mention that there's the concept called contract ABI. That means abstract binary interface. That is basically the interface of the contract. That means what it means by interface means that this has this function, and this will be need this sort of output input. This will output this type of the type of the outputs and sort of things. So that concept will also be very useful for you when you are getting started with Ethereum. So that's for the contract part. So building the front end, you can use any front-end web development framework, maybe Angular, maybe React, maybe just a HTML page. So if you are using Angular or React or something, you can basically have the npm package for Web3. And if you are just building an HTML front end, you can use the browser module. Like just you import the jQuery module, you can import it within a script tag. So as I said, the truffle framework provides a useful environment for you to test your contracts. So testing is something important in every programming task. So truffle framework will be the best option for you to test your contracts. And truffle boxes means truffle boxes provide basically boilerplate codes for you to start. Maybe there are even with the front end as well. And I thought I would mention about consensus as well, because as I said earlier, they are providing that Infura service, which let you to access any of the node, any of the test networks or any main network itself for free. You don't really have to worry about running a network by your own. So it basically taking the infrastructure to the burden of infrastructure to themselves, and let the developers develop applications and test them. Basically, that will be really useful for testing purposes as well. Apart from that, the truffle framework itself is also supported by consensus, and the MetaMask plugin I earlier introduced was also introduced by the consensus lab. So I just thought of that it's better worth mentioning their service. So that's pretty much the tools that you have around. Maybe I may have missed one or two, but to get started, those things will be really useful. So now you may kind of have idea of what type of tools you have to get started with Ethereum, but you may kind of still not sure what would be the flow. So Chim will basically give you an understanding what sort of flow you should follow. Yeah.
Can you all hear me? Hope so. Yeah. What I would try to do is I'm trying to kind of simplify the concepts or the tools and things that you have to use to develop blockchain application with Ethereum. I'm trying to kind of draw a simplified sequence of what you need and why you need certain different tools. Yeah, actually, this is one slide that Achala missed. So Achala has created a small sample application which you could simply, clone and start running with the blockchain. It has a smart contract already deployed, so you'll be able to start interacting with that and get some feel for like how to work with a blockchain or blockchain application or a dApp. Yeah, I mean it's 2 slides. I'm trying to create a sequence of what you would need and how you would work with a dApp. So to do this, I'm going to give a slightly different definition for blockchain. Say we have to think of blockchain as a ledger, like series of transactions. So as a developer, you would be adding transactions to blockchain. So in a nutshell, you can, ultimately that's what you would be doing. You'll be doing so many other things and you would create a transaction and you would add that transaction to blockchain. So if we consider that's what you would do as a blockchain developer or Ethereum developer, I'm going to take you through certain steps which would clarify why certain things would be needed. So to start with, we have a transaction and we have the network. So the transaction, you can think of it as a record in a database, like a record with multiple attributes. So we need to get this into the blockchain. So how to do this? What you would need to do this is what I'm going to explain. So you have a transaction, a set of information that you like to store in the blockchain or send a transaction to the blockchain. For you to do this, you need an account. Account is it is basically a key pair, a private key and a public key. So the public key is basically how anyone would know you from. Like if your public key is what you would go to someone who need to transact with you. So you need an account. But having an account is not enough. You basically have to sign your transaction with a private key. So you need a private key. The key pair, as I mentioned earlier, the public key and the private key is required for you to sign a transaction. So the requirement comes for you to have this key pair. So the public key, as you would all know, would help you to, everyone would know you from your public key, but the private key will basically help you to, incorporate your identity into a transaction. So anyone else cannot pretend as you and send transaction if you sign it from your private key, which is a secret for yourself. So you need a private key. Then once you have a private key, for you to transact with blockchain, you need an ether balance. You have to pay for your transaction. So means you have to have some ether with you if you want to send a transaction to the network. So okay, how to get ether? Another barrier. Basically, what you have to do is you have to mine if you want to get ether for yourself. If you are in a real network, you could pay cash and get ether, or else you have to mine yourself and earn ether. But yeah, that is the requirement for you to have gas or ether or the wealth for you to get a transaction posted into the network, because that's how the miners will get benefited by processing your transaction. So this is another step that you have to have. So then you are kind of really ready to send a transaction to the blockchain. One more hurdle to go. Basically, your transaction, like say you have an application, you have all these things in place, but the network is out there. The nodes are out there, the peers are out there. You are in your computer. So you cannot really directly send your transaction to the blockchain network itself. So how it has been designed is you have to hand over the transaction locally to a node running locally in your computer. So then that node will slowly propagate that transaction to the rest of the network in a secure manner through the gossip protocol, as they call. So that is the way that a transaction could send out to the real network. So for that, you need to run a local network. I mean, running a local network and mining, I mean, you could do both of these things in the same go, like, with the same node. But these are the elements that you would need to get your transaction from your application to the blockchain. So these dependencies, I mean, if you started developing an application, you're gonna hit on all these walls one at a time. Like, yes, I need an account. Yes, I need to sign this. Where's my private key? Okay, I need Ether now. Where I could get Ether? Could I go ahead and mine, or is there any other way? Likewise, you would have to kind of face this. I mean, answer these questions if you want to transact with the blockchain. So this being the most difficult path that you could think of getting a transaction to the blockchain, there are some tools that could help you to make this process a bit easier. For instance, there are a tool called MetaMask. I think Achala mentioned that. So MetaMask is a browser plugin which you can install in your browser. Once you install that, you can create accounts through that, and it will secure your private key and store the private key in a secure manner. And it will help you to sign the transactions. Even you are developing an application, still the browser plugin could help you to sign your transactions. So that takes some burden out of our shoulders. So then getting Ether, I mean, yes, we have the one way of getting Ether is mining or buying it if it is in a live network. But there are faucets which you could ask Ether for. So providing your social ID, or there are some faucets which just give you Ether just by asking, if you ask. So through that, if you are in a test network, you could get some Ether from these faucets. So that make the life little bit more easier. Finally, now we can get rid of the mining. So if you use Infura, you can think of Infura as a web interface or web service, web API. What they do is they run their own local nodes behind that service, and they have exposed the web interface which we could do some simple REST calls and submit our transactions to the Infura. So they basically drop that transaction into a blockchain node, and that get populated from there onwards. So this would be kind of a path that you would have to go through if you want to get build an application and basically get transactions stored in blockchain. So this being said, like this is where the transaction is going. I mean, if you think of the Ethereum ecosystem, basically most of the time the transactions are sent to smart contracts. You could send transactions directly to other accounts, but most of the time the idea is basically you would try to interact with a smart contract. So again, you have a transaction. So usually it would end up in a smart contract in the network. So let's look at what a smart contract is. Smart contract, basically, you can think of it as a very simple program. So when it is a program, of course, as you know, you need a language to write it. So the Solidity is the most popular, and with the most Solidity is the language with most resources. So you could start developing smart contracts, especially if you are in Ethereum network. So you have to go ahead and learn a bit of Solidity. It's not difficult. You would have to spend a couple of days maybe to get up to speed with the syntax and things around it. So you definitely have to learn Solidity if you want to develop for Ethereum. So once you have written a smart contract, you have to go ahead and unit test it. The unit testing play a major role in smart contract development. The reason being, I myself wouldn't have written I don't know 1% of smart unit tests for a traditional program. But we can test it in the live environment or the live application itself, whether the logic that we have written is correct or not. But when it comes to smart contracts, for you to test the Solidity code that you have written, the journey that you have to take is so long. It could take even up to 15 to 20 minutes just to deploy your smart contracts, test whether the syntax or the logic that you have written, and find out a bug, and come back and fix it. Like, this journey could take about 10 to 15 minutes. So there's no choice in a way without writing unit tests to get a proper smart contract developed. So unit testing play a major role in smart contract, in my mind. So for this, there's this platform called Truffle. I think, again, Achala mentioned about that. It provides you an easy way of writing unit tests and running your unit test against your smart contract and make sure the contract logic is correct and accurate. So you have a tested smart contract written in Solidity. Now we have to go ahead and compile this. So the best option would be go for Remix. Remix is an IDE. You can code on that. You can compile your code, and you can deploy contracts through Remix. So it's a very useful tool. But for compiling aspect, of course, you can use Remix and get your code compiled. So once it is compiled, what would happen is it would end up in the bytecode. The bytecode is a code that could get executed in the Ethereum virtual machine. The Ethereum virtual machine is what would run on every single node in the network. So once we have the bytecode that represents the contract in an executable manner in the Ethereum virtual machine, now the challenge is how we could get this bytecode into the network or to the Ethereum virtual machine in your node. So to do this, again, ultimately what happens is this bytecode becomes we could use the bytecode as the data of a transaction that you are sending to the network. And once you send that bytecode to the network, to the zero address, null address, that creates a contract in the blockchain. So it would definitely follow the process that I earlier mentioned. Like, it would go through the exact process, and it will land on one of the nodes in the Ethereum network, and that will represent your contract in the network, in the Ethereum virtual machine. So I think that's pretty much. This is basically. I was trying to address this from two aspects. One is like simply how to get a transaction into the contract or the network as a transaction into the blockchain, and if you are receiving it at a smart contract, what you would need to build a smart contract to get that transaction. To receive future transaction. So I believe this would help you to. If you are starting with developments, these elements, when I myself and when I was talking to people, these has been the problems, most difficult aspects of understanding. We would have to spend a lot of time to get this sequence right, understand these dependencies right. So knowing these, I believe it will help you all to get started with the developments quite easily. Thank you very much.